Hi guys. So I kind of messed up in like the previous recording. So basically, what I'm gonna do in this video and in the last video that we did, we went over kind of slope and y-intercept, all that good stuff. Since I did already have just since I already do have a lot of videos based on that, I do want to move on to something more difficult. And I did go over, like I said, I went over interval and interval notation, all that good stuff. But now I want to kind of define so basically piecewise functions, right? Um, and we have also done, and I'm pretty sure that uh, these are in my YouTube channel as well. I have gone over how to graph quadratics, but when it comes to piecewise, I don't think I've actually, I haven't really gone so in depth with how to graph piecewise functions. So we're going to go over that in this video. And so I'm going to, so give me 1 second, guys. Okay, so we're gonna go over some basic rules of transformations of functions. Now, although I haven't gone over all the kind of functions that we go over in this video, or we go over in, like, although I haven't gone over all the types of functions in my YouTube channel, at least I don't think I have, we're gonna go ahead and just kind of, in general, define what it means to transform a function, or what it means to kind of reflect, or, so this is kind of going to be a very basic general video over just all those definitions, and we're going to do this, and the reason why I'm defining them now is because for the functions that we are going to go over in algebra, and that's not including, like, of course, we're gonna do polynomials, but we're gonna do more the rational, radical, logarithmic, etc. So I'm gonna go ahead and we're just gonna kind of go over the definitions. So the first thing that we need to understand is that the idea of what is called shifting. Now, I'm going to go ahead and just try to define these in general when it comes to, like, vertical shift, horizontal shift, etc. So when we talk about a vertical shift, hold on. So let's say our original function, is f of x, and the transformed function is going to be h of x. Let's just kind of say that, right? Now, when I talk about shifting of functions, so there's one part, and this is what it's called, a vertical shift, right? So, a vertical shift and if I'm gonna say, for example, c units up, what this means is my original function, like I said, is f of x, right? And the transformed function, given that if I do go up this many units, c units, it's going to be h of x, and we're going to say equals, and we're going to say f of x, and the way that it goes is plus c. So what that means is that when I have some sort of function, let's just kind of do a random curve, I don't know, I guess like this. And this goes for every function, guys. When I talk about, let's say this is f of x here. So that's f of x. And what I'm saying is that it goes upwards c units. So let's say that c, let's say it's right here. And this would be my transformed function of h of x. Would be f of x plus c, because it went up c units. That is what I mean by vertical shift, okay? And that's what vertical shift means when you're going upwards. Now, when you're going downwards, so this is number 2, a vertical shift or a vertical, I'm going to call it translation, actually, not shift. A vertical translation c units down. What I mean by that is, let's say again that my function is right here. This is my function f of x. Well, my other function, h of x, I'm going to just draw it in blue, is going to be f of x minus c. So I'm going down c units. So basically, let's say over here is my c value, and I'm going to go down. So basically, it goes from f of x, and then my g of x will be like right here. Meaning that this is going to be, or I'm sorry, this is going to be h of x, not g of x. H of x, which means I'm shifting down however many units my c says, right? So those are the first two, right? And now there's a third one that is a little more difficult to kind of grasp. This is, so basically we have, again, let's say f of x. We have a function f of x, right? And what if I say that the transformation says a horizontal shift or horizontal translation, or a translation, basically horizontal translation c units to the right. So now, this idea means that I'm going to go to the right however many units, whatever c is. So let's say, for example, again, let's say I have this kind of curve here of f of x. This is my original curve. And then what I'm saying is that, so like I said, this is f of x. And then my other one, which is h of x, right, will end up being this following way. So give me a second. We're going to just go ahead and put it right here. So this is going to be, so basically h of x, this is going to be my h of x right here. And let me actually, give me a second, guys. Okay, so now notice that h of x is actually, when we translate horizontally to the right, we're going to put f of x minus whatever that number is. So a very brief example, I'm just going to say, for example, let's say this is x squared, and I say f of x minus 3. Well, that means I'm going to go 3 units to the right, and this will be my f of x minus 3. This will be my translated function h of x. Right, so my translated function will be x minus 3 quantity squared. That is the idea of horizontal translation to the right. You're keeping this as a negative, okay? A lot of people think that when I say to the right, or when the professor or teacher says to the right, they mean that it's plus, but no, it's minus. You're going to go x minus whatever that number is, and etc., right? So we have to remember it's actually the opposite of positive, not, it's going to be minus. For when you go to the right, you're subtracting inside the parentheses. You're not adding, okay? So that is the kind of the tricky part about it. And also, when I do again, so horizontal translation to the left, this means that we go from f of x to h of x by saying that h of x, and again, h of x, I'm going to put it as blue, is equal to f of x, and I'm going to say c units, right? C units to the left. So this time, we're going to add c inside the parentheses. So this is a rule that we just have to remember. For me to learn this, I had to understand that negative inside parentheses means to the right, and positive outside means up, right? So, and negative outside means down, etc. So basically, when this is positive like this, we know that this is going to be to the left, okay? And I think this is one of the hardest things to remember about college algebra, is that, you know, when it comes to translations, reflections, you know, stretches, compressions, etc. So basically how that looks is, I'm going to say, well, I have, for example, here's f of x again, and if I go to the left, c units, it looks like this. So here's c over here, and I'm gonna go to the left. So now we're gonna go ahead and just do another parabola over here, and this is gonna be represented, this part here will be represented by h of x, right? And so, hold on, guys. So basically, this blue parabola here now, so again, if I say this is f of x, then this is h of x, and it is defined by f of x plus c, okay? So basically, it's going to be, you know, like I said, it's a little bit tricky, because now we're going to the left. It means this is left c units, okay? So it does not follow the rule of, like, if it's positive, it means to the right. If it's negative, it means to the left. No, it's not like that. If it's negative inside of the parentheses, it's the opposite. So negative means right, positive means left. And that is how I remember these. Okay. And I think I already went over all this stuff. So now what we're gonna do is we are gonna go ahead and now talk about stretches and shrinks, I think. Give me a second, guys. Okay, actually, let's first do reflections. So when when I talk about reflections, so another thing is reflections. So, and again, this is one thing that a lot of students forget. This does have a lot to do with kind of even in odd functions, because if you think about it, it's somewhat similar, like the notation, but these are two, like, they do kind of correlate with each other, but you know, it's a little different. So when I say, for example, a reflection about the x-axis, what I mean is I go from f of x to f of, and I'm gonna say negative x. So I'm gonna say negative x. So that is a reflection about the x-axis, I think. Or no, I'm sorry. Oh my god. About the y-axis, excuse me. Okay. So, basically, when we do a reflection about the y-axis, that is f of negative x, right? So, I'll give you guys an example. And actually, hold on. Yeah, so that is a reflection about the y-axis. So for example, let's do the parent function of y equals x, and I'm only doing this, or I'm gonna just show you guys a graph representation of this. Okay, so here we are on Desmos, and how I want to show you guys when I talk about reflection about the y-axis, a good example of this is when we talk about the square root of x. So obviously at least I don't think I have gone over these as much, but this is a good example. So when it is reflected about the y-axis, we can kind of see that just the general kind of a general drawing of this, and it doesn't have to be literally graphed exactly, but you can kind of see that this is how the kind of the square root of x looks. And when we translate it, so if I say, or I'm sorry, when I reflect it, if I say reflection about the y-axis, what I mean is I'm literally reflecting about this line here. I'm reflecting about this line here. So that means I'm going to grab all these points and I'm just going to move them to the other side. So I'm going to do this and I'm going to do this. And what that is going to be is it's going to be the other curve that is represented by the reflected function. And like I said, it doesn't look exact, but you'll see exactly what I mean. And now this is actually going to equal to the square root of negative x. So basically that is what the transformed function is. So that is a reflection about the y-axis. And if you see that over here, and if I put square root of negative x, you'll see that by the blue line, there's this like reflection here, and the line of reflection is x equals 0. This is the line of reflection, and you can just see that they're kind of equidistant from each other. What I mean by equidistant is like they have the same distance to the y-axis. So I'll just kind of explain that a little bit more, just so you guys know exactly what I'm talking about. This basically means that I have, so this point here is reflected and it goes 1 unit and then another unit over here, because this is 1 unit and this is 1 unit. So basically there's this kind of like, that is a reflection about the y-axis. That is, it's kind of like a mirror, right? If you remember from geometry, reflections basically meant that they mirror each other in a way. So that is the idea of reflection about the y-axis. Now, about the x-axis is a little bit different. So when I talk about the reflection about the x-axis, so I'm going to use the same example. Hold on. So, basically, if I have the kind of the same curve here, I'm going to do the same curve. I'm going to just do like that. Actually, not like that. I'll do it like this. And I know this is y equals square root of x because we just graphed it, right? And so then what I'm going to do here is I'm going to just reflect this about the x-axis. So I'm going to say, well, it's going to be, so this is again my line of reflection. This is the x-axis here. And when I reflect that, it's going to mirror this side over here. So basically what's going to happen is this. I'm going to have another curve that mirrors these points, so they're equidistant from each other. So this is the same distance as this, right? They're the same distance from the line of reflection. So meaning that we're going to go ahead and just do this one, and then there's also this point here, and it's equidistant from that point there. So it's like right here. So it's going to be over here basically. And this is like, it's right here. Okay. And when I talk about a reflection about the x-axis, and watch guys, it's going to be the square root of, it's going to be negative the square root of x. So basically, it's going to look like this. So you see how, and now the line of reflection is now y equals 0, which is the x-axis basically. We have to remember that y equals 0 does not mean the y-axis, it means the x-axis. And x equals 0 is the y-axis, okay? So, you see how they're kind of equidistant from each other. You see, like, this part here, this part over here is the same, so that this distance here is the same as this distance over here. So, that is the idea of reflecting about the x-axis. And so we can say that the reflection about the x-axis is really going to be defined by negative f. So it's going to go from f of x to negative f of x. Okay, and that is the idea about reflections in the x and y axis. Now, vertical and horizontal stretches and shrinks are a little more difficult, so I think I'm gonna stop the video here, because when it comes to vertical and horizontal stretch and shrink, it's yet another, like, kind of, it's another another like set of terminology that I just don't want to do in this video because I don't want to make it longer than what it has to be. So I'll say that this is kind of part one to this video, and then I'll make another video later on how to do vertical stretch and shrink when it comes to just like the basic definitions of vertical stretch and shrink, as well as horizontal stretch and shrink, because those are a little harder. So with that being said, guys, I really do appreciate everybody watching, and also please like, comment, and or subscribe. And if anybody does have any questions over this, please let me know. And with that being said, guys, thank you so much for watching, and I will see you guys in the next video. Bye, guys.